All right, let's dive right in. Today, we're tackling one of the most exciting and, yeah, kind of mind-bending frontiers in all of technology, quantum computing. But before we get into the nitty-gritty, I want to start with a huge question. Just imagine for a second a computer so powerful that it could solve problems in minutes that would take our absolute best supercomputers today thousands of years to crack. Seriously, what would you even do with that kind of power? That's the incredible promise we're exploring today. So, what exactly is it? Well, to put it simply, it's a completely new kind of computer. It doesn't use the normal everyday physics we're all used to. Instead, it taps into the weird and frankly powerful rules of quantum mechanics to process information in a way that is just fundamentally different. So here's our game plan for this explainer. We're going to start with why we even need a new kind of computer in the first place, and then we'll take a peek inside the quantum world itself. After that, we'll look at the absolutely incredible problems it could solve, and finally, what the road ahead looks like. Okay, so Section 1, Beyond Bits and Bytes. To really get the why behind quantum computing, we first have to talk about the limits of the computers we use every single day. You know, everything on your phone or your laptop is built on one simple idea, the bit. Think of it like a light switch. It can be on or it can be off. It's a 1 or a 0. But a quantum computer uses something called a qubit. And a qubit can be a 0, it can be a 1, or, and this is the part that changes everything, it can be a combination of both at the exact same time. And that ability to be in multiple states at once, well, that's where the explosion in power comes from. With just 100 of these qubits, you can represent a number of possibilities that is just astronomical. It's way, way beyond what any classical computer could ever dream of handling. This is where that quantum speedup comes from. And why does that matter? Because some problems are just too complicated for the computers we have now. Take trying to create a new drug. You have to simulate how a molecule behaves, right? But all the tiny interactions between its atoms create this dizzying number of possibilities. A classical computer gets totally bogged down trying to calculate every single one by one. It's like trying to describe a beautiful painting to someone who can only see in black and white. And that brings us right to Section 2, inside the quantum world. Okay, so we're about to get into some pretty strange territory here, but stick with me. These 4 principles are basically the quantum toolkit that makes all of this possible. So the whole magic trick relies on harnessing 4 key phenomena. We've got superposition, entanglement, interference, and then there's the big one that engineers are always fighting against, decoherence. Let's just take them one by one. First up, superposition. This is that kind of magical property we were just talking about. The ability for a qubit to be in a mix of all its possible states at the very same time. A really great way to picture this is to think of a spinning coin. While it's in the air, spinning, it's not really heads or tails, right? In a way, it's a blend of both, until it finally lands and you measure it. A qubit in superposition is just like that spinning coin, holding a huge amount of information all at once. Okay, next up is entanglement. Now, this one is famously weird. Einstein called it spooky action at a distance. It's this deep, almost mysterious link between 2 or more qubits. They become so connected that their fates are literally intertwined, and it doesn't matter how far apart they are. So what that means is, if you have 2 entangled qubits, even if they're on opposite sides of the universe, and you measure one and find out it's a 1, you instantly know the state of its partner. It's this incredibly powerful connection that lets quantum computers handle ridiculously complex information. So you have all these possibilities swirling around in superposition. How in the world do you get a single correct answer out of it? Well, that's where interference comes in. You can think of this as the engine of the whole quantum calculation. It's a way to carefully control the qubits so that the paths leading to the wrong answers cancel each other out, while the paths to the right answer get stronger and stronger. It's a lot like how noise-canceling headphones work. They create sound waves that are the exact opposite of the noise around you, and when those waves meet, they cancel each other out. Silence. Quantum interference does something similar, but with probabilities, making the right answer get louder, so it's the one we see at the end. And finally, we have to talk about the great challenge, decoherence. See, this whole quantum state is incredibly fragile. The tiniest little thing from the outside world, a stray vibration, a little bit of heat, can make the qubit lose all its quantum superpowers and just collapse into a boring old classical bit. This is why quantum computers have to be so carefully shielded and kept insanely cold. Which brings us to the really exciting part, Section 3, solving impossible problems. Okay, we've seen a little bit of how it works, but what about the so what? How is this technology actually going to change our world? Well, the potential is just staggering. We're talking about breakthroughs in designing life-saving drugs, discovering new materials to fight climate change, building way more powerful AI models, and even modeling our incredibly complex financial markets. All of these are basically about finding the single best answer in a sea of billions of possibilities. And that's exactly what quantum computers are built to do. I absolutely love this quote because it just nails the difference. A classical computer has to brute force its way through a problem by crunching every single number. But a quantum computer? It's different. Because it operates using the same quantum rules that nature does, it can build a model that mimics reality directly. It's a whole new ballgame. And because this is so transformative, you better believe people are investing. The quantum computing industry is projected to be a $1.3 trillion market by 2035. This isn't just some niche academic thing anymore. This is a full-blown technological revolution in the making. Which brings us to our final section. The future is quantum. Let's take a look at the actual concrete steps being taken to get us from the labs of today to the reality of tomorrow. Now, it's really important to know where we are on the journey. In 2023, we hit a huge milestone called quantum utility. That basically means quantum computers can already solve some specific problems that are just impossible for classical computers to simulate. The next big goal, which folks are hoping for around 2026, is quantum advantage. And that's the point where a quantum computer can give us an answer that is provably better, faster, or cheaper than any known classical method. And the roadmap is getting clearer all the time. Companies like IBM have put out some really concrete goals. And notice they use the term logical qubits. These are super robust, error-corrected qubits, and they're a much better way to measure real power than just counting the physical ones. The goal is to hit 200 of them by 2029, and then 2,000 by 2033, capable of running a billion operations. These are the real, tangible steps toward building these world-changing machines. So you see, the quantum age isn't really a question of if anymore. It's a question of when. We are building a tool that lets us understand and work with the universe at its most fundamental level. So the only real question left is, what incredible things are we going to discover with it?